Hi students, I am your chemistry miss. Today we are going to see the continuation for the fourth lesson, that is the last topic, the inner transition elements. So that inner transition element, that is the lanthanide contraction. So that and actinide. Today we are going to see the lanthanide contraction and the actinide. First we are going to see the what is mean by lanthanide contraction. So first you are understanding what is mean by lanthanide contraction. Lanthanide contraction. So what is the word meaning of contraction? That is shrink. Okay, so that is the shrink of this atomic size and the ionic size of this atom. So the atomic size is decreases. What is mean by lanthanide contraction? First we are going to see the atomic size decreases. Okay, atomic size decreases. What are the elements? So that is lanthanum to lutetium. Lanthanum to lutetium. What is that atomic number is? The atomic number 57 to here that is 71. Lanthanum to lutetium, totally 15 elements. Okay, so the atomic number, so from left to right in the periodic table, from left to right, the atomic number increases one by one. So that is, we already know that the atomic number increases one by one. How it will be increases? Suppose proton will increases one proton increases, mean automatically electron is also one number of electron is also increases. What is the meaning for that? So that is added in this. The protons are added in the nucleus. Protons is added in the nucleus, but the electrons are added in the 4f subshell. Okay, so protons are added in the nucleus, but the electrons are added in the 4f subshells. Again, you are understanding the more concept here. First I am writing here, that is the one atom. So this is the nucleus. Then again I am surrounding the 6 orbital. 1, 2, 3, 4, 5 and the 6 orbital, right? So this is the nth shell. Which one is 4f shell? We already know that. So that is the penultimate shell. So that is called as a 4f subshell. So here which one is? That is 1, 2, 3, 4, 5, 6. So that is what is meant by penultimate shell. The last shell is called as, this one is called as nth shell. This is n minus 1. This is n minus 2. The n minus 2 is called as penultimate shell. So that is called as 5f shell. Okay, that is the 5f shells. The electrons will be added. That is the 4f, right? 4f shell, the electrons are added. So the lanthanum, the protons are added in the nucleus, but the electrons added in the subshell. So again you are understanding more, you are understanding. So that is the last electron. So here the electron is here. This is the nucleus, the attraction. So here attraction is there. Before that, the 4th orbital. So the here is also electron is there. S orbital, P orbital, D orbital. The electron is also in between here. So that is the last electron. The between the 2 orbital, the electrons are repulsive in nature. What is the reason? What is the repulsive reason? Because both are same charge. Okay, so that is the reason, that is repulsive force. But here the protons are the positive charge, right? This is the nucleus is positive charge. This is a negative charge. The positive charge, the negative charge will be attraction. So what is the what is the result? The attraction will be with the nucleus and the outermost electron. So the atom will become shrink. So but the atom started to shrink, but here that is the electrons are the active against the repulsive force. So that is the reason it is act as a screen. So that is apart from the screen, it will apart from the screen, it will attract towards the nucleus. So that is called as screening effect. Screening effect or shielding effect, right? Screening effect or shielding effect. So that is the reason. So the attraction. So here the 4f orbitals are poor shielding. So that is the reason the 4f orbitals are poor shielding. So it is easily attract towards that nucleus. So the remaining s orbital, p orbital, d orbitals are more shielding effect. But when compared to s orbital, f orbital, the f orbitals are poor shielding effect. Okay, poor shielding effect. That is the reason it is not screen that attraction. So it is most attract towards that nucleus. The atom size will be shrink. Okay, this is the basic concept due for the lanthanide contraction. So lanthanide contraction, the atomic size will be decreases from lanthanum to luteum from left to right. So from left to right, that is the number is 57, 58, 59 up to 71. So in this each orbital, 1 electrons are added in the proton. The same time 1 electrons are added. One electrons are added in the electron subshell, that is 4f subshell. These electrons are added in the nucleus. So as a result, what will happen, that is 4f subshell, the attraction will be more with the nucleus and the outermost shell. But here in between the f orbitals are act as a shielding effect, but here the f orbitals are poor shielding. So that is more attraction with the nucleus proton and the outermost electron. So that is as a result, the atom becomes shrink. So that is called as lanthanide contraction. What is meant by lanthanide contraction? Due to the more attraction with that inner orbital, that is the nucleus and the outermost electron, the atom become shrink. So that is as a result it will become, that is the poor shielding effect. Due to the poor shielding effect here, that is s orbitals are more shielding effect when compared to p orbital, then d orbital and the f orbital. The f orbitals are poor shielding effect. Poor shielding. The 4f orbitals are poor shielding effect. So that is what is the reason? It is diffused in that the 4f orbitals, in this 4f, the electrons are diffused in nature. What is mean by diffused? So these 4f electrons are diffused. What is mean by diffused? That is spread in that orbital, spread among these 4f orbital, that is spread is scattered in that orbital. That is the reason. It is also another reason. First one is poor shielding of the screening effect, and another one is the 4f orbitals are diffused. Okay, so that is the lanthanide contraction. What are the 4 causes of this lanthanide contraction? So first one, what are the 4 lanthanide contraction? That is the first one. What is the first one? Nuclear charge increases. Nuclear charge increases by 1 by 1. Nuclear charge increases and the under addition of electron. Okay, first one is, suppose you are adding that new electrons, mean the nuclear charge will be increases. Second one, 4f subshells as diffused in shape. Okay, the 4f subshells diffused in shapes. Okay, so 4f electrons also, 4f subshells also poor shielding effect. Poor shielding effect. And another one is effective nuclear charge increases. So another reason. What are the reason for the causes of this lanthanide contraction? Effective nuclear charge increases. What is mean by effective nuclear charge increases? The more attraction with the nucleus and the outermost electron. So that is proton and the outermost electron, right? More attraction. Outermost electron or valence electron. So the more attraction, that is also increases. Okay. So next one, with the increase in the nuclear charge, valence is full towards that nucleus. Due to this increased nuclear charge, valence shell pull slightly towards the nucleus. So size of lanthanum, that is 3+ ion, decreases. Okay, so this is the reason for the lanthanide contraction. What is the reason? First one is nuclear charge increases. in the 4f subshell, it is diffused in shape. Another one is the 4f orbitals are poor shielding effect, and the effective nuclear charge increases the proton and the outermost electron, the attraction will be more, and due to this increased nuclear charge, so the lanthanide, the nucleus will attract towards that nucleus outermost electron, so that is, so size of this lanthanide ions are decreases. Okay, so this is the causes of this lanthanide. Then consequences of this lanthanide contraction, that is consequences. What is the consequences of lanthanide contraction? First one is some cerium to lutetium. Some cerium to lutetium, the atomic size decreases. The size of atom decreases. What is the reason? So reason from left to right, decreases the atomic size. So what is that? The cerium to from left to right, the atomic number increases one by one, right? From left to right, decreases the atomic size because of this increased nuclear charge. The atomic size decreases. Okay, but the first, what are the consequences? First topic is basic character. What is meant by basic character? So basic character from cerium to lutetium, so the size gradually decreases in size basis of lanthanide. Okay, so the size from cerium to lutetium, okay, the size gradually decreases. The size of the atom gradually decreases in size. What are the bases of lanthanide? So the basis of lanthanide is represented as, so Ln thrice. So how to explain that? Suppose lanthanide. So lanthanide, this is the first point. The size of the atom decreases. That this is the lanthanide basic character. Second one, lanthanide hydroxide, right? Is I suppose it will ionic character, means what will happen? OH minus ions are liberated, released the OH minus ion. But in the covalent character, but these bonds are covalent character, covalent in nature, what will happen? Covalent character, what will happen? So increase, that is the OH minus ion is not released. Okay, the OH minus ions are not released. So that is the covalent character, that is the basic character decreases. Basic character decreases. What is the reason? According to the Fajan's rule. So the Fajan's rule explain. What is Fajan's rule? The Fajan's rule, more covalent character, the basic character will be decreases. So the Fajan's rule is to, they explain that covalent character is increases. Covalent character increases. Covalent character increases. Basic character is also increases. Basic character is also increases. Okay, so that is the reason the size of this atom, size of atom is inversely proportional to the covalent character. So here, that is the lanthanide hydroxide is a, suppose it will ionic in nature, means the OH minus ion is easily liberated, but the Ln-OH, the bond is covalent is character, the basic character decreases. What is the reason? According to this Fajan's rule. What is meant by Fajan's rule? The covalent character increases, the basic character decreases. Okay, the basic character decreases. So that is the size of this atom is inversely proportional to the covalent character. This is the first point. Second point. The second point is, that is atomic radii. So the atomic radii, radii 10 pictometer, ionic radii that is 20 pictometer. So what is the difference between the 10 and 20? Well, that is the slight difference. So that is it is both are atomic radii, ionic radii. Similar means the physical and chemical properties is also similar. Chemical properties is also similar. Physical and chemical properties is also similar. So it is more difficult to separate from the minerals. So difficult to separate from the minerals. Okay, it is more difficult to. So how to separate this element from the repeated fractional crystallization? Okay, so this is the method we can separate these elements. Again, the ion exchange method. Okay, this is the another one. So again, so that is the reason the bottom of the periodic table, the 4f orbitals are present in the bottom of the periodic table. So another one in the d block elements. So in d block elements, what are the series? You remember that? So what are the series are present in the d block element? 3d series, 4d series, 5d series and the 6d series. The 3D series is called as, what are the 3D series? The 3D series is called as first inner transition element. 4D series is called second inner transition element. The 5D series is called third inner transition element. This is fourth inner transition element, right? So the 3D series, that is 3 to 12 elements. So that is the D block elements, right? So this is the another one. The 5D series only, that is lanthanum, that is lanthanum to 14 elements are between here, after then to hafnium to mercury. Okay, so these are elements in the 5D series, right? The 6D series is also, but here the second size, the third transition series, the second series, what is the second series? That the 4D orbital in the D block element, the 4D series and the 5D series. So that is the atomic size. So similar atomic size of this, the transition series, that is 4D transition series, the 5D transition series, the size is almost similar. So that is the both sizes are almost similar or the size are same. So the physical and the chemical properties is also same. So that is the reason. What is the reason? Because of this lanthanide contraction. The lanthanide contraction, the atom size are similar to the 4D series. So that is the reason the atomic radii, the ionic radii, that will be decreases. That is similar to the 4D series. Okay, this is the another point. What is the first point? What are the first point? First point is the basic character. Lanthanum 3 plus ion decreases. Second one is atomic radii and the ionic radii. This is the second one. Third one is the D block element. The 4D series and the 5D series is the similar physical and the chemical properties. What is the reason? The 5D series, the lanthanum is present in the 5D series. So that is, it is mimic structure as a 4D series. Okay, so this is the consequences of the lanthanide. Okay, so next we are going to see the actinides. Okay, so next we are going to see the actinide. So what is mean by actinide? Actinide series, the elements containing, what are the, how many elements? Again it is also the actinium to lawrencium. So that is, so here the 89 to lawrencium is atomic number is 103. So that is 15 elements are present. So that is 15 elements are present there. Okay, so this is also present in the bottom of the periodic table. So what are the properties? First one is all the elements are radioactive in nature. Okay, this is the first point. All the actinides are radioactive elements. Okay, this is the first one. Second one, the half-life period is also very small. Half-life period is also very small. Very small half-life period, and also it is the very short-lived. Okay, so this is the three things for the actinide. Actinide is all the actinides are radioactive element. half-life period is very small, and also it is also short-lived. Okay, so this is the another one. So next one is the thorium and uranium. What is the occurrence of these elements from thorium to thorium and uranium is also obtained. Considerable amount is obtained in the nature. So that is the considerable amount is present in the nature. And plutonium is obtained in the trace amount is obtained, and the remaining elements are artificial radioactive element. Remaining all other elements are at artificial synthetic element, artificial element. Okay, so this is the occurrence. So next we are going to see the how to remembering the name of this elements. Okay, how to remembering the name of this element. I am giving one trick to this remembering this one. So how to remembering this trick. So first one is, so how to remembering that actinide series. I am writing one trick. So that is Thor. What is mean by Thor? That is one powerful character in America. So that is Thor. And protected. Okay, the Thor protected. That is the, what are these? That is the planet's name. What are the planets? Uranus, Neptune, then Pluto, and America created better confirmation, better California, that is not considering that one. Then Einstein, friends, Mendel and Nobel, and Laurentian. Lawrence. Okay, so this is the trick I am writing here. So then you are writing that number, atomic number 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, then 103. Okay, I am writing that element number, writing according to that order. Okay, so next one is, so how to write that name. Okay, so Thor. So what is mean by Thor? That is thorium. I am writing that name here. Thor means that is thorium. Then protected, that is protactinium. Then Uranus, uranium. Then Neptunium. Then plutonium. Then americium. Then curium. Then perchelium. Then californium. Then einsteinium. Fermium. Then mendelevium, nobelium, and Laurentium. These are the elements name. Okay, so this is thorium, protactium. So according to that trick, Thor protected Uranus, Neptune, Pluto, America created better California with Einstein friends, Mendel, Nobel and Lawrence. Okay, so these are all the trick. So according to that number, you can write that name: thorium, protactinium, uranium, neptunium, plutonium, americium, curium, perchelium, californium, einsteinium, fermium and mendelevium, nobelium and the lawrencium. Okay, these are the elements. So next one is how to write the electronic configuration of this elements. Okay, how to write the electronic configuration of this element. What is the general electronic configuration? So that is here. What is the general electronic configuration? How to write the general electronic configuration? So the atomic number 90, atomic number 90 to 103. So nearer that, what is the nearer noble gas configuration? That is radon. Atomic number is 88, right? Atomic number of this radon is atomic number of radon is 86, right? So this is the 86. Then how to write this electronic configuration? Radon 5F, then 6D. So lanthanide we write 4F, but here that is 5F, 6D and the 7S. So S orbitals are completely filled. 0 to 2 will be coming in the 6D orbital. F orbital 2 to 14 will be coming. Okay, so this is the general electronic representation of this 5F orbital. Okay, so next we are going to see the how to write the electronic configuration of this actinides, right? That is the general electronic configuration 7s2, that is 0 to 2, and 5f 1 to 14, that is 2 to 14. Okay, so how to write this electronic configuration, right? So here this is a small trick here, that is I am writing here all this. I am writing all this electronic configuration, that is 89, 90, actinium, thorium, protactinium, that is uranium up to lawrencium. Okay, this is how to write. First one is, you remember that number, how to write that number. So here 1 to 14 elements are there, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, that is 15 elements. But here, that is in this first element, 1 is not coming. So just you remember that 1 is not coming, right? Then again, what are the number? And the another one is 5 is also not coming. 8 is also not coming. So instead of 1, 2 times 0, right? 2 times 0. So I am writing here, that is the 5f orbital. So what are the number present in the 5f orbital? So that is 2f, that is 0. So 2 times 0, right? 2 times 0. Then again 2 will be coming. 2 will be coming. Then 3 will be coming. 4. 5 is not coming. So directly you write 6, right? Directly you write 6. Then 7. So then again 8. 8 means that is lost one electron. It is attained the octet, the half-life, that is the half-filled configuration. So that is 7. So then 9. 9, 10, 11, 12, 13. Here also 14 instead of 15, that is 14, and 14, that is 2 times. So here that 5f orbital, what are the elements present in the 5f orbital? So small trick I am writing here, that is 88. Just you remember that, that is 88. Okay, I am writing all that values 88. So you have to find out that d, that is the number of electron present in the d orbital. So that is the small, just small calculation. Okay, just you are adding the two number, then you subtract that atomic number. 88 minus 89. So that is, this will be okay, so this is 88. So what are the element in the d orbital? that is d orbital, that is 2 orbitals also. First one is 88, that is 1. 88 plus add, that is 88. 90 minus 88, that is 2. Then 88, 100, 100 minus, that is 1. Here also. Okay, then again 88, 91, that is 1. Here also 88 plus 4, 92, again 1. Okay, 3 times 1. Again 86, 94, 94, 94, that is 0. Here also 0. Then 1. Then 0. 0, that is 97. This is 98. 0. Then 0. Then 88 plus 12, that is 100. 100 is also 100 minus 100, that is 0. Then again 101. 88 plus 101, so that is 0. This is also 0. This is also 0. So okay, so that is the number of electron present in the d orbital. Now you can write the electronic configuration. But using this electronic configuration, you can write this atomic number, electronic configuration of this elements. So first one is okay. So first one, how to write this electronic configuration? I am using that one. You can write this electronic configuration. I am writing here all these elements, right? First one is thorium. So what are the elements present in that thorium? Okay, so here this is the thorium. So here that is radon 5F67S, right? So I am writing here radon is 86. 86, what are the 5F? That is 0. Okay, 7s2, I am writing full 2 electrons. So yes, orbital containing 2 electron. I am writing here 2 electron. 2 electron, here also 2 electron. Okay, 2 electron. So 5F orbital. Now you can fill. This is the 5F orbital. From this one I am writing here, that is 2, 3, 5, 4. I am writing this. This is the number. This is the 5F orbital. I am writing that number. I am here, that is 0, 0. Okay, 0, 0. Then 2, 3, 0. This is 2, 3, 4, 5, 6, 7. Here also 8 is not coming. This is also 7. 4, 5 is not coming. Writing here 6. Okay, this is 7. Here 9, 10, 11, 12. Then 30, 14. Then 14. Okay. Then 6d orbital. So what are the element present in the 6d? So I am writing here thorium onwards. So okay, that is 2. Here 2. Here 1. Then 1. 2, 1, 1, 1. Then 2, 0. That is 2 times 0. Right? 0. Then 1. 1. Actually, then again 0. Up to all elements are 0, right? 0, 0, 0, 0, 0, 0. Then finally this one will be 2. Okay, so this is only 2. This is the easily remembering the electronic configuration of thorium 2. That is the 5F orbital. So F will be, how it will, F will be coming. So that is the number I already told, that is 1, 5, 8. The 3 number is not coming. Instead of 1, you can write 0. Then 2, 3, 4. Instead of 5, you can write 6, 7. Then instead of 8, you write 7. Again 2, 7 will be coming here. Then instead of 14, again 14 will be coming. That is 2 times 14. So that's why I am writing here. This is the 5F orbital. Then using this trick, so that is 88. You are adding the 2 number. You can subtract that number. Okay, that is 88. So subtract, that is 2 number. So that 88, So 88, 90, 91, 91, that is 1. Using that number, you can write that one. Okay, so this is the another one. So next we are going to see the oxidation state of this actinides. Okay, so first one is the actinides are exhibit variable oxidation state. Variable oxidation state. Oxidation state. Okay, variable oxidation state. Then again, so in lanthanide, that is +4 oxidation state is more common, but here the oxidation state will be exceeds more than +4 oxidation state, right? So then again, so how it will be explained, what is the reason? So 5f 6d 7s orbital, the energy gap between the 5f orbital 6d orbital are very small. The energy gap are very small. So that is the reason the electrons are occupied, and also the 5f orbitals are high shielding effect. High shielding effect. High shielding effect. Due to this property, the oxidation state will be variable oxidation state. Another one is common oxidation state is common oxidation state is +3 oxidation state, right? So what is the common oxidation state? That is +3 oxidation state. Another one is what are the oxidation state? Variable oxidation state is so what are the oxidation state? +2, +3, +4, +5, +6 and the +7. Okay, so these are all the variable oxidation state. So what are the element exhibit in the oxidation state? So first one is thorium and americium. So first is thorium and americium, that is Am. That is the two elements are exhibit in the +2 oxidation state, right? Then all elements, so common oxidation state is +3. The all elements exhibit +3 oxidation state, right? So then thorium to alkenium, so that is perclinium. So that is thorium to perclinium. Thorium to perclinium. So here that is the thorium to from these to perclinium. So these are exhibit the what is the oxidation state? That is +4 oxidation state. Then thorium to americium. Then again thorium to americium. So thorium to americium, that is exhibit what oxidation state? That is +5 oxidation state. Then uranium to americium. Then uranium to americium exhibit +5 oxidation. Uranium to americium exhibit +6 oxidation state. Then neptunium and the plutonium exhibit +7 oxidation state. So americium exhibit in the, and also americium is also exhibit +7 oxidation state in aqueous solution. Aqueous solution, it will exhibit +7 oxidation state. Okay, so this is the another one. So these are all the oxidation state, variable oxidation state in the 5f orbital. So next one important question is, what are the difference between, what are the important lanthanide and the actinide? Okay, so this is the important one. What are the difference between lanthanide and actinide? So I am here. First one is differentiating lanthanide and actinide. So first one is differentiating electron enter in the 4f orbital. Lanthanide means that is 4f orbital. This is 5f orbital, right? So differentiating electrons enter in 4f orbital, but here differentiating electron in the 5f orbital. And another one is the binding energy of 4f orbitals are higher. Always the binding energy is higher than compared to actinides. Actinides are lower binding energy. Then they show less tendency to form complexes, but here the lanthanides are show less tendency to form the complex, but here that is greater tendency to form complex. These are the colorless. Lanthanides are always colorless, but here the most of the actinides are colored from the uranium 3+ is the red color, uranium 4+ is green color, uranium oxide is yellow in color. Okay, so this is the another. Okay, next point is they do not form oxocation, but they do not form the, but lanthanides are oxocation because it is forming we react with oxygen to form the cations, but here that is not forming the oxocation. But that here, that is +3 oxidation state. Lanthanides are the common oxidation state, show +2 +4 oxidation in few cases. But here that is +3 oxidation state is common. Higher oxidation state is also exhibit, that is +5 +6 +7. Okay, these are all the, that's all about this fourth lesson. Fourth lesson is completed. Then next we are going to see the fifth lesson. So this question is very important, difference between lanthanide and the actinide. That is repeatedly asking question. What are the difference between lanthanide and actinide? Okay, so you learn, so you watch that video. I hope you will understand all that video. Okay, see the next video. Thank you, children.